In the previous video, we kicked off the Pinterest Money course. Today, we'll continue by discussing keywords and writing a Python bot for their quick research and parsing. So, why are keywords crucial? It's simple. No keywords, no traffic. To ensure people discover our pins, we need to gather keywords and incorporate them into title, description, and file name of the uploaded pin. Since we're dealing with traffic and large volumes of content, our approach to keywords should be fast, high quality, and free. For instance, what if we have an offer in the keto diet category and we want to quickly research keywords with just that phrase on hand? And we can do this with the help of the Answerthepublic service. Just take a look. We input the keyword, select the region, and get information on search volumes, along with numerous keywords that have traffic and are conveniently categorized. On the free plan, we have 3 searches per day, but we can only export 30 keywords. So today we'll write a bot that saves all keywords, organizes them into category files, and compiles all keywords into a single overall file. But more on that later. Now let's talk about another great service. Remember in the last lesson when I discussed how searches work on Pinterest? What was the point of that information? It's because these search suggestions can also be collected. For this, you can use the Keyword Tool service. Choose the Pinterest tab and enter the keyword. On the free plan, it doesn't show all keyword data, but it's not critical for us. Sometimes you need to clean up the list by removing unwanted words. To do this, enter these undesirable words in the negative keywords field. You can copy these keywords to the clipboard and then save them to a file or export a CSV file. Another good service for keywords is Ubersuggest. It's also from Neil Patel, like Answerthepublic, so it's somewhat similar. However, Answerthepublic provides more data and extracting it is easier, so I usually use it. All right, let's summarize the knowledge we've gained with the help of this mind map, and then we'll proceed to develop the Answerthepublic parser. So what can we say about this service? Data here is dynamically loaded through JavaScript. To get 3 daily searches, you need to register an account and log in. On the free plan, we can export only 30 keywords. Based on this, we need to write a bot that will log into the account, enter data, perform a search, parse the keywords, and write them to a file. We'll also add the capability for the bot to work with multiple accounts and operate through proxies. Let's start developing the bot. First, open PyCharm and create a new project named Keyword Parser. Now let's install the necessary dependencies that we will need during development. Let's install them using the terminal with the following command. Next, let's create the basis of our bot. Create a file named main.py, which will serve as the entry point for our application. We will launch parsers from this file. To implement the logic of parsers, create a package named modules. Now let's create a file for the parent class and declare the base class parser in it, where we'll extract common elements of our parser subclasses to avoid code duplication and establish a hierarchy. We'll use the mechanism of inheritance, where our parser subclasses will inherit from the parent class and extend its functionality. Let's create the files for 2 parsers, Answerthepublic and Keyword Tool. Let's declare classes in them and leave them empty for now. In this lesson, we'll only be writing the Answerthepublic parser. The Keyword Tool class is here to demonstrate the mechanism of inheritance. Additionally, let's create a file for the Account Manager class. This will be an independent class, not inheriting from others. So the bot class structure is as follows. 2 child classes, Answer and Keyword Tool, inherit from the parent class parser, along with 1 independent class, Account Manager. Let's plan the work of our bot to understand which methods need to be created in our classes. So we need to retrieve account data, log into the account, parse the data, write the data to a file. So we need to create methods for these tasks. Let's create the templates for these methods. We need direct access to these methods from outside the class, so we should make these methods public. The others can be made protected or private. So in the Account Manager class, let's create a public method called getAccounts. For now, we'll leave it empty. In the Answerthepublic class, let's create empty methods for login and parsing. In the base class, we'll create the write to file method. We create this method in the base class because this method can be a common element for different parsers. Now in the main py file, let's create the handling of instances of our classes and outline the launch logic. Create two functions, Answerthepublic and keyword tool. Leave the keyword tool function empty for now. In the Answerthepublic function, create an instance of the account manager class. Import this class. Now call the getAccounts method from it and assign the result to the variable accounts. Create a loop to iterate through each account in the list. In the loop for each account, we will create an instance of the Answerthepublic class and store it in the variable answer. Import this class. Then, through this instance, we will call the login method. Next, for each keyword that we pass to this function as a list, we need to call the parsing method. Now create a conditional if name statement that will serve as the starting point. Create a list with keywords for parsing. Then, call the Answerthepublic function and pass the list of keywords as the first argument. The initial skeleton is ready. Now let's move on to refining and elaborating on our classes. Let's define the attributes of our classes to understand what arguments we need to pass to the constructors of our classes and methods. The development of the folder structure in our project, where the parsing results will be stored, will help with this. To start, let's create a folder named Projects. Since we will work with various themes, we will create folders by theme. Let's create a folder called Keto. In each folder, there can be results of parsing by different parsers, so we will create folders Answerthepublic and keyword tools. In the Answerthepublic folder, there will be folders with the name of the keyword we are parsing. Inside this folder, there may be folders with the results of parsing on Google, YouTube, Bing. Let's create these folders. The folder structure of our bot will look like this. Now let's implement the automatic creation of these folders in the bot. We will have a common element for the two parser classes, Answerthepublic and keyword tool, which is the project folder the parser works with. Let's add this common element to the constructor of the base class. Pass the variable with the project folder name into the constructor as an argument. Then form the path to this folder. Now create an instance attribute named project path. Next, let's create a static method that will create a folder at the specified path and return the full path. A static method is a method that is not bound to an instance of the class and does not have access to its attributes. This means it cannot use self to refer to the instance. Static methods are used for operations that are related to the class as a whole, but do not depend on a specific instance. Let's assign the result of calling this method to the instance attribute project path. This attribute will contain the path to the project folder, which will be created automatically. Now let's form paths to the Answerthepublic and keyword tool folders, as well as to the folder with cookie files. Next, create attributes and assign the results of the static method makeItHere. In this way, all the folders of our bot will be created automatically in one place in the program, and we will be able to access the attributes with their paths through instances of child classes from the base class. When accessing these attributes, the interpreter will look for them first in the instance of the class, then in the class of this instance. If not found, the search will continue in the base class. Now, let's go back to the main PI file and inside the entry point. Declare a variable with the name of the project folder we will work with. Pass this variable as an argument to the Answerthepublic function, then accept this argument and pass it to the constructor of the answer class. Okay, let's continue refining our classes. Let's work on the implementation of our child class answer. First, let's create the constructor of the class and think about what arguments it should take. First of all, it's the working folder. Now let's open the login page and see what data we need for loop. We need an email and a password. Pass these arguments to the constructor and create corresponding attributes in the object. Also, let's add the ability to work with proxies and the browser's operation mode so that we can work in headless mode. We can see that the init method is highlighted. This is happening because we haven't called the constructor of the parent class and haven't passed the required argument there. Let's fix that. To call the constructor of the parent class, we use the super function. Now, create an attribute with the browser object and a static method that will create it. Pass the proxy and browser operation mode there. Set their default values. Specify the logic of the method and return the browser object. Also, let's not forget to import undetected Chroma driver. Now let's implement the login method. Its logic will be as follows. If a cookies file is found for the account containing session data, we read that file, load the cookies into the browser, and automatically log in. If the cookies file is not found, we open the login page, enter the login details, log into the account, and then save the cookies for future logins. Let's implement the first part of this logic. To start, let's create two class attributes. Assign the website address to the first one and the login page address to the second one. Let's also construct the path to the cookies file. For this, we'll create another attribute and assign it the result of the join method from the OS module. The cookies path argument will be obtained from the base class and will form the file name from the email. We'll use the pickle module to work with cookies. So let's set the file extension accordingly. Next, let's write a static method that checks for the existence of the cookie file. We'll make it private since we only need it within the class. Now we can implement the first part of our login method. Let's move on and implement the second part of our login method. To do this, we need to define attributes or selectors for the fields, where we'll input the data. Open the login page, right-click to bring up the context menu and select Inspect to view the page source. Then, use the pointer to hover over the relevant element. You can identify the element by its name or ID. Let's find it by ID. We can locate the element directly, or we can write a method that waits for the element to appear on the page. Let's apply the latter. Let's create three methods that may come in handy later. One will wait for the element to appear, the second for the element to become clickable, and the third for the element to disappear. These methods will take the criteria for checking, the value and the waiting time as their arguments. If the element is not found within this time, we'll raise a no such element exception and output the element's value. If the element is found, we'll return it. Note that these methods are not static because they need access to the instance attributes, specifically the driver. Let's go back to the login method. After the else block, let's create a try block where we'll handle the login process. First, navigate to the login page by calling the get method on the driver object and passing the attribute with the login page address. Now let's find the element with the email input form and store it in a variable. After that, we'll input our email. Following the same principle, let's input the password. Now let's find the button to confirm the login. Locate it by class name and click on it. Wait for the button to disappear, then save the cookies for future logins. If anything goes wrong, handle the exception and print it to the console. Alright, now we can test the login functionality. For now, let's not connect the account manager. We'll do that later. Let's comment out these lines for now and pass the email and password explicitly. Disable headless mode and run the bot. After logging into the account, keep an eye on any windows that appear during the process. Fill in the necessary details to prevent these windows from interfering with the bot later. You can also set the default country and language. Now let's determine what the bot should do after logging into the account. It needs to choose a source, select the country, choose the language, enter a keyword, and click the search button. Let's create templates for these methods. These methods will be private since we only need them within the class for implementing its logic. External access to them is unnecessary. Let's implement these methods one by one. Let's start with setting the country. As usual, we first identify the attribute or selector of the target element. For the country, it's the ID region. Since this element is a drop-down list, we need to create an object of the select class and pass the found element as an argument. Now let's use the method to find the text in this drop-down list. We'll pass the variable with the country name, making the first letter of each word uppercase using the title method. We'll write a similar method for choosing the language, changing only the element's ID. In the method for entering the keyword, we'll find the element by ID and then input the keyword. Now, let's find the search button by class name and click on it. Finally, let's write a method to set the search source. First, let's find the block with the source buttons. Locate it by class name. Now let's implement a check. Since Google is our default, if the mode argument passed into the method equals YouTube, we find the corresponding button using a CSS selector. We make another check for Bing. Then, we click on the element. Now let's move on to our parse method, which will serve as a hub for smaller methods that will run in the required order. First, let's open the main page. Now let's define the arguments that this method will take. The first will be the keyword, followed by the source, country, and language. Let's set default values for these arguments. After that, we'll choose the search source if it's not equal to Google, which is the default. Then, we'll select the country and language if they are not equal to the default values. Next, we'll input the keyword and click the search button. Now, let's set a delay for data loading. During parsing, I noticed that data is not always returned on the first attempt. Sometimes we need to refresh the page to get the data. So after the delay, let's refresh the page and wait for an additional 20 seconds. Let's test the bot. All right, the data is loading. Now we need to get the HTML code of the page and then parse it using the Beautiful Soup library. Let's retrieve the HTML code, then create a Beautiful Soup object, pass the HTML code, and specify the parser. Now let's form the path for the saved files and create the necessary folders. Note that we call the makeDir method from the base class. Even though the method is protected, we can access it from the child class. Let's now identify which blocks in the code we need to search for. Each block is enclosed in a section tag with the attribute data source name equal to the name of the corresponding section. Inside these blocks, there are lists with the class modifier list. The keywords we need are the elements of the list enclosed in a div block with a class containing modifier suggestion. Let's implement the parsing of these keywords. First, let's create a separate method to which we will pass the mode and the beautiful soup object. Now let's find the section with the attribute corresponding to the passed mode. Inside the section, find the lists with the class modifier list. Let's create an empty list to add keywords. In a loop, iterate through each list from the found lists. In each list, find all div blocks with a class containing modifier suggestion. Then, for each div, retrieve the text using the getText method and add the result to the text list. Finally, return the prepared list. Now let's go back to our parse method. Create a list with the types of keywords to parse. Next, in a loop, iterate through each type and call the parsing method. Pass the keyword type and the beautiful soup object. Store the result in the keywords variable. Print information about the collected keywords and call the method to write them, which we will later write in the base class. At the end of the loop, concatenate the keywords into a common list. After the loop, print information about the total number of keywords and write them to a separate file. Now, let's write a method for writing keywords to a file. Go back to the base class. Our method will take the following arguments: a list of data to write, the file path, the file name, and the option to choose between writing to a text file or a CSV. Now, let's write the method. First, let's form the full file path. Now, implement the logic for writing to the file line by line, depending on the file format. Now, let's go back to the answer class and add an argument for the file format to the parse method. Also, I made a mistake when forming the path for the saved files. We need to swap these arguments. All right, the code is written. You can test it now. Now let's connect the account manager. If you don't want to use an account manager, you can just use a dictionary and fetch data from there like this. However, let's create a manager. Go to the account manager class. The account manager is independent of the specific project folder, so we won't inherit this class from the base class. We'll make it standalone. Create a constructor where we'll create an instance attribute that will contain the path to the account manager's CSV file. Next, create a static method that will automatically determine the CSV file delimiter. The account manager file will consist of these columns. Now, let's implement the method. First, check if such a file exists in the target folder and raise an exception if it doesn't. Now, determine the delimiter and store it in a variable. Next, create an empty list for results. Now, open the file, skip the first row with the header and create a reader object. Then for each row, check if the account is enabled by looking for a 1 in the first cell. If it's enabled, retrieve the data from the remaining cells into a dictionary and add the dictionary to the list. If the list is empty, raise an exception that there are no accounts enabled. If not empty, report how many accounts are enabled and return the list. Now create a CSV file, fill it with account data, save it as account CSV, and move it to the data folder. In the main PI file, uncomment these lines. Also, let's go back to the base class and replace these lines with these. This will be more accurate. All right, we're done. You can now test the parser and perform the final parsing. We have already parsed keywords from Google. Now let's test parsing from Bing to verify if the bot correctly selects the search source. If you need to change the country and search language, pass them as the third and fourth arguments. For now, I'll leave the country and language as default and only change the search source. Firstly, I want to mention that you can download the entire code from today's lesson in my Telegram channel through the link in the description. Now here's what you need to do. You need to understand how the bot works and run it. Use the bot to parse at least 500 general keywords for each offer chosen in the first lesson. Supplement the list with Pinterest suggestions gathered using the Keyword Tool service. Enter the keywords into a Google Sheets table with 3 columns. That's it for today. Next time, we'll prepare a video and write a bot that will parse links and download videos from TikTok. See you in the next video.